So you want to become a data scientist. Maybe you're pivoting from a different field, or maybe you've just graduated and you're looking at this mountain of skills to learn and conflicting information about how to prioritize your time, and you're wondering, where do I even begin? Well, don't worry. In this video, I'm going to walk you through the exact steps to go from zero experience to landing your first role as a data scientist in 2025, without a bootcamp or advanced degree. You'll learn what skills to prioritize and in what order, how to build real-world experience before you even have a job, how to make your resume and LinkedIn stand out, and how to excel in tricky technical interviews. We'll even talk about what life is like in your first role, so you know what to expect and how to get your career started on the right foot. I put together a free ebook with all of the information covered in this video, along with links, checklists, and more. Link to that is in the description. Quick intro if you're new here, I'm Marina. I'm an applied scientist at Twitch or Amazon, where my role is kind of like a hybrid between a data scientist and a machine learning engineer. I also mentored a machine learning bootcamp and coach people one-on-one on how to break into the field. I actually transitioned into data science myself from a non-technical background, so I know firsthand how challenging and rewarding this path can be. As a little motivation, I earned 5 times what I did before transitioning into the field, while at the same time having a better work-life balance and a more engaging day-to-day now than I did back then. Now right away, let's address a question you might be worried about. Is it even still worth it to become a data scientist these days? With all the layoffs in tech and the increasing presence of AI, it's natural to question whether data science is still a smart career choice. Here's why I believe that it is. First, while the tech layoffs have absolutely been real, they don't tell the whole story. Even with recent cutbacks, data science remains one of the most in-demand fields. According to the US Bureau of Labor Statistics, employment of data scientists is projected to grow 36% from 2023 to 2033, which is much faster than most other professions. So sure, the competition is tougher now, but that doesn't mean you can't do it. You're just gonna need to put the work in to make it happen. And what about AI? It's true that AI is reshaping industries, but it's not eliminating data scientist roles, at least not yet. More importantly, I think the core skills you'll develop, programming, statistics, critical thinking, are valuable across many industries, so even if you need to pivot in the future, you'll be well prepared. So while it might be harder to break into data science now compared to a few years ago, the rewards are absolutely still there for those who are persistent and focused. If you're willing to put in the effort, this path can lead to a well-paying, intellectually rewarding career with plenty of growth opportunities. Let's talk about how long this process is going to take. You've probably seen videos or courses promising you can become a data scientist in just a few weeks or a few months. While that might be realistic for someone with a super strong technical background and a lot of free time, for most beginners, it's just not. Data science isn't easy. It's not a job where you're just going to learn a few simple things and then coast. Building the necessary skills takes time, but it's worth that investment. This is definitely a marathon, not a sprint type of situation. I would say if you can dedicate about 20 hours a week to learning, this 12-month timeline that I'm gonna lay out will guide you step by step from beginner to that first job. So if you're starting in January, this timeline fits perfectly. But if not, don't worry, just use it as kind of a flexible template. Let's break it down. The first 6 months are all about establishing a strong foundation. During this phase, you'll learn the essential skills every data scientist needs while also starting to build your network. So first things first, we're gonna start meeting people. Find local meetups, Discord servers, or LinkedIn communities where data scientists connect. Building relationships early will help you down the line, whether that's finding mentors, collaborators, or even job opportunities. Plus, you'll start learning the language of the field and the kind of things people are working on, which is going to be really helpful when you're coming up with projects and preparing for interviews. This is your reading and practicing phase. We're going to start with beginner-friendly courses, books, and YouTube tutorials to dive into the fundamentals. Throughout this phase, we'll work on follow-along projects and courses, as well as some small self-directed projects to apply what you're learning. Around halfway through this first phase, say around March or April if you're starting in January, you should be confident enough with the basics to showcase your new skills and start getting a feel for the job market. At this point, we'll update your LinkedIn and resume with the skills and projects you've worked on so far and start applying to jobs casually. We're not necessarily having the goal of landing a job right away, but more practicing and getting feedback. Every application and potentially interview will teach you something for later on. After this phase, it's around July. Now that you've got a solid foundation, it's time to tackle your first self-directed end-to-end project. You're going to want to think of a project that demonstrates your skills comprehensively, such as scraping news websites and running sentiment analysis about a particular topic to track trends over time, predicting the genre of a song based on its lyrics, building a recommendation system for something that interests you, like board games or podcasts, whatever the case may be. Or maybe you make something like a crypto price prediction model. Your goal at this point is to stretch yourself to apply your skills to new problems that you can add to your resume and speak confidently about in an interview. Now that you have some experience working on projects independently, it's time to try getting some experience working with real clients. You're going to start reaching out to family friends, local small businesses, nonprofits, anyone you think might work with you, and offer your data skills for free. For example, you might volunteer to analyze customer data for a local shop or build a dashboard for a nonprofit. These real-world projects will boost your portfolio, build connections, and give you a lot more confidence in interviews. We'll talk a lot more about how to do this in the How to Get Experience section. We'll also want to ramp up job applications around this time, but we're not going to just apply through job boards. Instead, we're going to proactively reach out to recruiters and hiring managers. Much more on this in the How to Get Interviews section. Lastly, we'll use this time to start building a habit of practicing coding problems like LeetCode and SQL so that we're ready when it's interview time. By September, we should be working on a second or third major project. Ideally, this should be for a real client that we reached out to, but if we don't hear back, just keep working on larger scale, self-directed projects that simulate real-world use cases as much as possible. We'll also keep networking, applying to jobs, and grinding out coding practice. By around November, your skills and portfolio should be solid, so it's time to shift gears to interview prep. This is something we can do with or without a specific interview lined up. In addition to the coding practice we've been doing, we'll also want to start thinking about preparing for case studies and presenting our work in the best possible light. I'll talk about interview prep in more detail later on in the video. By December, all your hard work should be coming together. Stay consistent and keep pushing until you land that first role. At this stage, you should still be applying to jobs daily, leveraging your network, and keeping your LinkedIn active with posts about your projects. You're also going to want to continue practicing coding challenges and preparing for interviews. With persistence and the right strategy, you'll land your first data science role and start 2025 ready to hit the ground running. One of the first decisions you'll need to make on your journey is understanding the type of data science role you're aiming for. As a beginner, you might not know that data scientists can do very different things at different companies. In my experience, there are three main areas of focus: analytics, data science generalist, and machine learning or production-focused roles. Each has its unique set of skills, day-to-day tasks, and career paths. So let's break down what each one involves and the pros and cons of each. If you enjoy diving into data to help businesses make better decisions, an analytics role might be the right fit. These roles focus on extracting and interpreting insights rather than building complex machine learning models. You'll often work closely with stakeholders to solve business problems through dashboards, reports, and A/B tests. These roles are generally more collaborative and less likely to have significant heads down time. Some typical tasks might be analyzing trends in sales, customer behavior, or operational efficiency, creating dashboards and visualizations to present data clearly, running experiments like A/B tests to optimize business strategies. Some pros. These roles often have a strong business impact and can be rewarding if you like problem solving in that context. They typically have a shorter learning curve for beginners since they rely more on data wrangling and basic statistical skills. This is a really great foundation if you're eventually interested in broader data science roles. Some cons. So, on the other hand, they can be less technically challenging. If you're looking to dive into machine learning or advanced statistical modeling, this maybe wouldn't be totally satisfying for you. Also, the compensation can be slightly lower than specialized data science or machine learning roles. Like the name implies, data science generalist roles require a mix of skills, from data wrangling and statistics to building predictive models. If you really like variety and flexibility, this path allows you to work across the entire data science pipeline, from exploratory data analysis to deploying basic machine learning models. Some typical tasks might be cleaning and analyzing data to uncover patterns, building and testing predictive models, and communicating findings through visualizations and reports. As far as pros, it offers a wide range of learning opportunities since you'll touch many different parts of the data science workflow. It opens up multiple career paths, allowing you to specialize later on in analytics, statistical modeling, machine learning, or other things. And it often requires less technical depth in machine learning, but it still gives you a solid broad foundation. In terms of cons, you'll need to be flexible and comfortable working on different types of projects, and the breadth of skills required can feel overwhelming at times, especially if you're just starting. If the technical and engineering side of data science sounds fun to you, a machine learning focused role might be the best fit. These roles are also most likely to allow you to have solo deep work time and are generally less collaborative than generalist or analytical roles. So some typical tasks might be developing machine learning models, deploying those models to production systems, and potentially working on advanced algorithms for things like computer vision, natural language processing, or recommender systems, for example. As far as pros, it's a highly specialized skill set that's in demand, especially in tech-driven companies and especially right now. It often offers higher compensation due to the technical complexity and lack of talent to fill open roles, and there's an opportunity to work at the cutting edge of technology, which can be kind of fun. As far as cons, there's a steeper learning curve, especially for those without a technical background, and it requires more engineering-type work, which may or may not appeal to you. So which one should you choose? For this roadmap, I'm going to assume you're going to aim for the data science generalist role. It's a great starting point because it provides flexibility and opens doors to both analytics and ML-focused positions in the future if you choose to go that path. That said, the advice in this video applies across all three paths and more. The key difference really is in what you prioritize in your learning. So for analytics roles, we're going to focus more on SQL and data visualization tools like Tableau or Power BI, and business problem solving. For machine learning focused roles, you'd want to dedicate extra time to programming, advanced math, and machine learning algorithms. For more senior roles, you'll also need to understand ML system design. For example, I started with a background mostly in statistics, and I kind of fell into machine learning by chance. It just so happened that that was an even better fit for me, and now I really love the engineering side of things, so ML is my focus. With your focus decided, let's move on to the core skills you'll need to succeed. There are many different paths to learning the skills to become a data scientist. You could go the traditional route with a degree, or you could join a bootcamp or teach yourself. For this roadmap, I'm going to assume you're going the self-taught route. It's often the fastest, the most flexible, and obviously it's the least expensive. But even if you're pursuing a degree or bootcamp, this guide will still help you fill in the gaps because trust me, no matter what formal program you're in, there's always going to be some self-study involved. That said, having an advanced degree can help. It won't guarantee you a job, but it won't hurt either. Resume scanners love seeing masters and PhDs, and without them, you might struggle to be considered for some roles. Still, some data scientists break into the field without one, so don't let it hold you back. Now, one big question I hear a lot is whether to start with math or coding. So my take is start with both. I think this is a good approach because they are equally essential. If you don't enjoy either one, then this probably isn't the field for you. And it's important to figure that out before you dedicate a ton of time to something you don't even like. But don't worry, you don't need to master calculus or become as good at coding as a software engineer right away. The idea is to start with the basics of both and build them up together as you go. Here's how we're gonna do it. Spend the first month learning the basics of both math and programming. For example, study Python for data analysis while brushing up on essential statistics. As you progress, pair them together. When you learn about a concept like regression and statistics, implement it in Python. This integrated approach is going to make the material more practical and easier to understand anyway. So another big question, should you bother with certificates? There are many paid online certificate programs available for data science. I think many of them are decent quality and the certificate can't hurt, but I wouldn't prioritize it unless it's no problem for your budget. You'll get further demonstrating your skills through self-directed learning than through follow-along programs, and it's free, so why bother? A quick note on effective studying. So data science concepts can be really challenging to understand. AI tools like ChatGPT can be super duper helpful for learning, debugging, clarifying concepts, but it's important to not let them do all of the work for you. That straining, kind of uncomfortable feeling of wrapping your brain around a concept is exactly how you grow. If something's hard, lean into it. Use ChatGPT to help, but always aim to understand the why behind the answers and let yourself struggle a bit before you just ask ChatGPT to explain it to you right away. Because sometimes it's not going to be able to. And you need to have the skill and mental endurance, to figure things out on your own. So with that mindset, let's jump into the specific skills you need to prioritize, starting with Python. Python is the main coding language used for data science, and for good reason. It's versatile, beginner-friendly, and it has a massive ecosystem of libraries tailored for data analysis and machine learning. As a data scientist, you'll spend a lot of time coding, whether it's cleaning datasets, building models, or automating workflows. While some companies may use R, Python dominates the field. The good news, though, is that once you've mastered Python, transitioning to R if you need to, or really any other language, isn't that hard. To get started with Python, we're first going to learn the very basics. So variables, data types, loops, conditionals, and functions. We're going to understand how to work with data structures like lists, dictionaries, sets, and tuples. We need to know how to do basic things like handle files, read and write operations, and dealing with exceptions. Next, we'll need to understand package management systems like pip and conda, at least just at a very high level. We just need to know how to install and basically manage dependencies for your projects. Then we'll want to get familiar with the main libraries used by data scientists. Pandas and NumPy for data manipulation and numerical computations, Matplotlib and Seaborn for data visualization, and we'll start with scikit-learn for building machine learning models. The goal here isn't to memorize every function, but to become comfortable with the tools and learn how to reference documentation effectively when you're stuck. When it comes to learning resources, don't get too hung up on deciding which Python course to take. Any reputable beginner course will do, just pick one and stick to it. Some good options are Code Academy, there's a Python for data analysis ebook I can recommend, and then of course, plenty of courses on Udemy. I'll make sure to link all of those in the ebook I have referenced in the description. This is honestly enough to get started. But if you want to stand out, as you're working on projects throughout the next year, pay attention to things that make your code clean and legible. For example, doc strings, comments, type hinting, and breaking up your code into easy to understand modules. In terms of timeline, plan to spend about 4 weeks mastering the basics of Python that we went over. To solidify your learning, here are some example projects to put things into practice. So you could build a Python script to process and analyze text files. First, you just write a program to read in the text file, then count the frequency of each word, maybe identify the top 10 most frequent words, plot them, and save the results to a new file. Or you could build a command line tool for basic arithmetic operations, so basically a calculator. You could write functions for addition, subtraction, multiplication, and division, take user input and perform the selected operation, add exception handling to manage things like invalid inputs or division by 0, and then print the results. At the same time, we're going to start studying statistics. As a data scientist, you'll use statistics in nearly every aspect of your work, from analyzing datasets to evaluating machine learning models and even designing experiments. The better your grasp of statistics, the better your ability to interpret results and not make huge mistakes that cost the company millions. Just kidding, kind of. We really do want to know what we're talking about when we make decisions based on data. Just like with Python, start with the basics and build your knowledge over time. Here's a roadmap of some key topics. So descriptive statistics, you want to understand measures of central tendency, so the mean, median, and mode. Learn measures of dispersion, like variance and the standard deviation. Explore common distributions, like the normal distribution, skewed distributions, and the uniform distribution. You'll want to understand data characteristics, like being able to differentiate between continuous and discrete variables and nominal versus ordinal data, and learn how to identify and handle outliers. You'll want to understand correlation and multicollinearity, and learn about multicollinearity's implications for regression models. We'll also want to have an understanding of inferential statistics, so hypothesis testing, including p-values, z-tests, t-tests, and chi-squared and ANOVA. We'll want to dive into basic probability concepts, including Bayes' theorem and randomization. Need to understand confidence intervals, and also learn about sampling techniques, resampling methods, and common statistical biases. From there, we can go into the basics of experimentation. So we can understand how to design and analyze A/B tests, including how to determine the appropriate sample size, how to decide how long to run a test, the importance of randomization, and that kind of thing. As a bonus, if you have time, it's awesome to explore causal inference techniques to evaluate cause and effect relationships when we can't run an experiment. In terms of learning resources, there's a Udemy course that I took really early on that is a super basic intro to a lot of this stuff. Then of course, StatQuest. That's honestly how I learned pretty much everything I know in statistics. It's a fantastic YouTube channel that breaks down complex topics in an easy to understand way. There's also Khan Academy, of course. And then a book that comes highly recommended. I haven't personally read it myself, but a lot of people have found a lot of value in it, called Practical Statistics for Data Scientists. You'll want to dedicate at least 3 to 4 weeks to studying statistics alongside Python. So it'll take 8 weeks total around to learn the basics of both. Spend the first week focusing on descriptive statistics and data characteristics, then move on to inferential statistics and experimentation in the following weeks. Here's some example projects to put this into practice. Download a Kaggle sales dataset and analyze the distribution of sales in each region and over time. Download a survey dataset from Kaggle to analyze stats for question answers, find outliers, maybe compare answers across different demographic or age groups, that kind of thing. Next, we're introducing another coding language, SQL. No matter where you work, you'll almost certainly use SQL to interact with data, because this is the language we use to query data from a database. While some smaller organizations may rely only on, CSV files, most companies use relational databases to store their data, and SQL is the primary tool for accessing and manipulating it. Luckily, it's pretty easy, especially if we just focus on the core concepts we need to get started in data science. So first, we'll want to focus on core querying skills. So we're going to want to learn how to write queries using select, where, order by, and limit. We want to understand how to deal with null values effectively to avoid errors or unexpected results, and get comfortable handling dates and timestamps. From there, we need to master joins. So we need to know the difference between inner joins, left joins, right joins, and full outer joins. We need to learn to use unions and self-joins for more complex queries, explore case statements to add conditional logic to the queries, and understand group by and aggregate functions, so average, sum, min, max, for summarizing the data. From there, some advanced techniques would be common table expressions, or CTEs, to break down complex queries into manageable chunks. We also want to learn how to write and optimize subqueries, and then we need to understand window functions like rank, row number, and lag to perform more advanced analytics on a dataset. This will almost definitely come up in interviews, so don't skip it. As a bonus, we also want to learn some basic strategies to make your queries run more efficiently. What we don't need to worry about right now is creating or managing databases or more data engineering stuff like indexing or sort keys. This stuff is absolutely useful for data scientists, but it's just not a priority right at the beginning. In terms of resources, any intro YouTube course or Udemy course is going to be just fine. Code Academy and W3 Schools also have options. You could also work through LeetCode or check out something like SQL Bolt. You'll want to dedicate about 2 weeks to learning the basics of SQL, and you can practice using the hands-on learning platforms linked. Next, we're on to data visualization. As a data scientist, a lot of your job is about telling a story with data. Data visualization tools like Tableau and Power BI allow you to transform raw data into insights that non-technical stakeholders can easily understand. So you don't need deep expertise in these tools to get hired, but being familiar with them and having them listed on your resume is definitely useful. For your first role, focus on the fundamentals of data visualization, both with dedicated tools and programming libraries in Python. So we'll want to go over the basics of Tableau and Power BI or equivalent software, like connecting to the database and exploring the interface. We'll want to create basic charts like bar plots, line graphs, and scatter plots, and then combine visualizations into dashboards, and adding interactivity is always cool too. So filters, slicers, that kind of thing. We're also going to want to understand programming-based visualization. So using matplotlib and Seaborn to make plots in Python. We're going to want to understand how to make these plots and also to customize them with titles, labels, legends, that kind of thing. And then how to highlight key insights in the analysis. As far as resources, any intro Udemy course would be fine. I've also seen some YouTube videos that are quite comprehensive, some 8 to 20 hours long. I don't think you need that unless you're targeting a really in-depth analytics role, but there's definitely resources out there at any level of detail that you're interested in. You'll want to spend about a week learning all of this, so focus on creating a small dashboard or a few plots that you can showcase in your portfolio. Some example projects to put this into practice would be making a sales dashboard, for example, in Tableau, Power BI. So you maybe, again, use that sales data set from Kaggle and create bar charts to show sales performance by category, maybe line charts for sales trends over time. You could use filters for interactive analysis by region or time period, and maybe highlight top performing regions or products. Then you could use a customer data set with demographics, purchase history, or behavioral metrics to create some clusters. So you could visualize clusters of customers using scatter plots, like spending versus frequency, and create demographic breakdowns using pie charts or bar charts. You could use Matplotlib or Seaborn to maybe make some kind of visualizations based on movie ratings analysis, for example. Maybe you get a movie data set from IMDb or Kaggle and create histograms to show the distribution of ratings. Then maybe scatter plots to compare ratings with box office revenue. Maybe you highlight trends and average ratings over time using line plots. And lastly, you could annotate key points or outliers. Next, we're on to Git. So as we learn, we need to have some way to save our code and projects and to share it with others once we build some portfolio. To do that, we'll use Git and GitHub. Git is a tool for collaboration and keeping track of your work. Whether you're working on a solo project or as part of a team, Git helps you save, organize, and track changes in your codebase. It also makes it easy to experiment without fear of losing any work and to share your progress with others. GitHub is the UI for us to interact with Git. So the things you're going to need to know: you're going to need to understand repositories or repos. These are kind of like folders for your projects that track all your changes to your files. We're going to want to understand how Git tracks changes to the files and allows you to move back to previous versions if you need to. We need to understand how to use branches to experiment with new features or ideas before affecting the main code base. We need to combine branches back into the main branch once your changes are ready using a merge. And it's important to understand how to handle situations where multiple people make changes to the same part of a file and we need to manage those conflicts. In the ebook, I'm going to include some basic Git commands you need to master, but they're going to cover basically all the same concepts as what I just discussed. I would really recommend checking out some of these resources. So learn Git branching. Oh My Git is a game. There's a really straightforward data camp course, and then of course we have Code Academy and W3 School, so plenty of options. We'll want to spend about half a week learning the basics of Git. Start by creating a personal project repository and practicing commands. As you work on projects, use Git consistently to develop good habits and really learn the skill. At this point, you've been studying for about 2.5 months. If you started in January, we're now around mid-March, and you've already built a strong foundation in Python, statistics, SQL, and data visualization. So the neat part is, you've actually got the skills to be a data analyst now. This doesn't mean you've completed your journey to becoming a data scientist, but it does mean you're ready to start marketing yourself as someone who's job ready now. So at this point, we're going to take some time to start putting yourself out there in the job market. First, we're going to update your resume and LinkedIn. We'll go over how to do all this in a lot more detail in the marketing your skills section, but this is kind of a teaser. So first things first, we need to add all the skills you've learned to your skills section on your resume and LinkedIn. Also, add a section for your projects, briefly describing what you did, the tools you used, and the outcomes. Make sure your LinkedIn photo is professional and approachable. Update your resume summary and LinkedIn headline or description to use keywords from jobs you'd like to target. Market yourself as already being the thing you want to be. So your headline shouldn't say aspiring data analyst, just you're a data analyst. Next, you need to update your GitHub. So make sure your GitHub is super clean with all your work so far. Again, we'll talk more about marketing this in the marketing your experience section. And now you're ready to start applying to jobs. So it may seem a little early, but we're gonna start applying now so that we start gaining skills, experience, and feedback. The idea here isn't to actually get a job. If that happens, that's awesome, but the idea is more to start getting a feel for what job descriptions look like, the skills they're looking for, keywords to target, and how you can tailor your resume and cover letter to these roles. Applications at this point are more information gathering than anything. Now, back to studying. Math is often the part of data science that intimidates people the most. The truth is, you don't need an advanced understanding of calculus or linear algebra to get started in the field. While a deeper grasp of these topics is absolutely useful for understanding machine learning algorithms and optimization techniques, it's not critical to be an effective practitioner early in your career. Many data scientists, myself included, developed a more in-depth understanding of math on the job as the work demanded it. I got my first job as a machine learning focused data scientist before I had ever taken a single calculus or linear algebra course, because I actually dropped out of high school and I never took it in college. I learned machine learning before I learned the math, and while that made some things a lot less intuitive, it wasn't a deal breaker. I learned the math later on my own through self-study. That said, having some basic math fundamentals under your belt will make it easier to understand key concepts like gradient descent, optimization, and certain machine learning techniques. So let's focus on what's essential and leave the rest for later. Linear algebra is important for understanding how data is represented and manipulated in machine learning models, so vectors and matrices. Calculus plays a role in optimization, such as understanding how gradient descent works to minimize error in machine learning algorithms. For now, we're going to just focus on these foundational topics. Linear algebra basics. Understand vectors, matrices, matrix operations, addition, multiplication, and the concept of dot products. For calculus fundamentals, you want to focus on derivatives and partial derivatives, enough to understand how gradient descent works, and learn the concept of gradients and optimization in general. We're not going to spend time understanding how to calculate this stuff by hand. Instead, we're just going to get an intuition for what's going on. Luckily, the perfect resource for this already exists. Just watch 3 Blue 1 Brown's Essence of Calculus and Essence of Linear Algebra playlists. If you want to dig deeper after that, I'd recommend Brilliant.org, which offers interactive lessons on linear algebra and calculus specifically geared towards practical applications, and Khan Academy. This is a classic resource for understanding the basics of calculus and linear algebra in a beginner-friendly way. Plan to dedicate 2 weeks to learning these math fundamentals. Again, focus on understanding the intuition of what is happening versus the calculations themselves. You can always come back to the math later in your career. Now we're ready to get started with the most fun part, in my opinion, machine learning. At its core, data science is about solving problems using data. Machine learning is one of the most powerful tools in your toolkit because it enables you to uncover patterns and make predictions from that data. Before diving into specific algorithms, there's a lot we need to understand first. So data cleaning, how to fix messy data, handle missing values, and deal with inconsistent entries. Feature engineering, we need to turn raw data into useful inputs for the model by creating features. Bootstrapping, so how to use sampling to estimate the properties of the data. Feature preparation, we need to handle common issues like scaling, imputing missing values, and normalizing features. From there, we need to learn about the train-test split and avoiding data leakage, so keeping the training and testing data separate to ensure the models generalize well. We need to understand exploratory data analysis, how to summarize, visualize, and explore data to spot trends or outliers. Next, classification versus regression. So understand when to predict categories, which is classification, or continuous numbers, regression. We need to understand supervised versus unsupervised learning, so the difference between working with labeled data or finding patterns in unlabeled data. And of course, metrics. So we need to understand regression metrics like mean absolute error, root mean squared error, and classification metrics like accuracy, precision, recall, and the F1 score, among others. Once you have some of this background, you can get started with some of the core algorithms. Begin with linear regression, logistic regression, k-means clustering, and decision trees. In terms of resources, I would recommend starting with Andrew Ng's ML Specialization, which is a classic, and you can also supplement with these YouTube channels. So Ritvik Math is really great, and then there's a gentle introduction to machine learning StatQuest playlist that's really great as well. Expect to spend about 4 weeks learning all of these fundamentals. Then we're ready to move on to some more advanced concepts to help us handle real-world challenges. So in this phase, we're going to learn about overfitting, so what it is and how to tackle it, regularization, so techniques like ridge and lasso regression to keep models from overfitting, cross-validation, validate your models properly by splitting the data into multiple training and testing sets, principal component analysis to reduce dimensionality and focus on the most informative features, hyperparameter tuning, ensemble models, so random forests and gradient boosting, so like XGBoost. I also think it's worth spending some time on time series basics, so how to analyze data over time, focusing on trends, seasonality, and just simple forecasting methods. And then we'll want to do an introduction to deep learning, so understanding the basics of neural networks, how they work, and when to use them. For resources here, I'd really recommend Andrew Ng's deep learning specialization on Coursera, and then also 3 Blue 1 Brown has a great series on neural networks. If you're targeting machine learning roles, I would really recommend the book Designing Machine Learning Systems for practical guidance on all of that as well. To put your learning into practice, do all of the exercises in the courses. We'll turn to self-directed projects soon. Expect to spend about 4 more weeks getting familiar with these concepts. You won't be an expert by any means, but this is kind of a survey of what exists right now so that you can use these tools in future projects. Speaking of things you should be familiar with, but definitely won't have time to master, we need to learn a little bit about cloud platforms. Cloud platforms like AWS, GCP, and Microsoft Azure are essential tools for modern data science. They allow you to work with large-scale data, deploy machine learning models, and manage resources efficiently. While you don't need to become an expert in all of them, you do need to know what they do and how to use key features in your workflow. AWS is the most popular, so unless you already know you're targeting a company that uses Google Cloud Platform or Azure, just focus on AWS. The concepts are similar with the others, and you can always learn them later. In particular, you should know the basics of storage and databases, so how cloud platforms handle data storage and how to access data securely, compute services, so how to use cloud resources to run large-scale computations or train models, and machine learning services like AWS SageMaker for training, deploying, and managing machine learning workflows. The ebook has plenty of examples for resources to learn as well. In terms of projects, just walk through the projects and the resources in the book in your own environment. You'll have plenty of time to practice with these in your own end-to-end projects later. You'll want to spend about 1 week exploring the basics, so just start with free tier accounts and get a little bit of hands-on experience that way. And then, like I said, when we're working on our larger scale projects, we're going to make sure to use these resources, so you're going to get a lot more experience with this then. Understanding the business side of analytics is also crucial for data scientists. It's not enough to build models. You need to interpret results in ways that drive business impact. Case studies test your ability to think critically about business problems, identify key metrics, and propose solutions that actually make a difference. These skills are really important for interviews, but also on the job, because business impact is how you move your career forward. Some things you need to know is how to investigate changes in metrics, so how to analyze why a metric like sales, churn rate, or engagement has changed. Understand common causes like seasonal trends, product changes, or external factors. You need to understand how to break down metrics into components, so maybe customer acquisition versus retention, to pinpoint areas of change. It's also important to understand key metrics for different kinds of businesses. So maybe for e-commerce, you want to understand conversion rates, average order value, customer lifetime value. For marketing, maybe you need to understand ROI, click-through rate, cost per acquisition, etc. In terms of learning resources, there are tons of mock interviews on YouTube, so I would definitely recommend checking some of those out. And then there are platforms like Interview Query that have practice questions where you can read other people's answers. I would suggest spending about half a week understanding the basics of business metrics and kind of this structured problem solving. Basically, just get your mind thinking about what these kind of things look like in general. It's going to take a lot longer to get good. Then we're going to dedicate additional time to practice in preparation before every interview. You're going to want to regularly work on mock case studies to refine your approach and gain confidence. The last thing on our roadmap is LeetCode style coding. If you're not sure what that means, basically it's a type of coding question where you're given algorithmic challenges to solve. They usually test your understanding of data structures like arrays, linked lists, and trees, and algorithms like sorting, searching, and dynamic programming, as well as computer science fundamentals. Personally, I despise LeetCode for data science interviews because, in my opinion, it's pretty much completely irrelevant for the kind of coding we do on the job. Data science typically involves wrangling messy data, building predictive models, and implementing data pipelines, not designing the most optimal binary search algorithm. But the fact is, a lot of companies still use it, so you need to know how to pass the interview. That being said, for most data science interviews, it'll just be questions on arrays and strings, so we don't need to go into software engineer level learning on data structures and algorithms. What I'd suggest learning is basic familiarity with Big O notation, common edge cases, and how to approach coding problems in general by asking clarifying questions, string and array questions, and then practice coding and speaking at the same time. For resources, I liked NeetCode's DSA course, but it is a little expensive. You could also just walk through LeetCode questions on arrays and strings, and then ask ChatGPT to help you understand the optimal solutions. I won't go into LeetCode in more detail here since honestly, I'm not good at it myself, and there are definitely better resources out there. But this is just a heads up that it's something you should have on your roadmap. Also, quick note that data science interviews also often test SQL, so don't forget to practice that as well. Dedicate about half a week to familiarizing yourself with LeetCode and solving some introductory problems, then start a habit of practicing one Python and one SQL question every day until you get a job. Now on to extra credit. There are some more things I think will be really valuable for you in your first job, but they're not essential. If you have time and curiosity, I would also recommend learning about how to test your code, object-oriented programming, code reviews, so how to give and receive constructive feedback on code, Docker and packaging, so the basics of containerization and how to make your projects portable. I would really recommend reading the Designing Machine Learning Systems book. It's an approachable book that really finishes the loop on putting systems into production. And there's another book called Software Engineering for Data Scientists that's just going to make you a lot better at that kind of stuff as well. Now, things not to learn. We've covered a lot, but there is so much more. Here are things I would skip for now. Deep learning for niche applications. So working with GANs, transformers, or advanced architectures is typically more relevant for specialized roles in computer vision or NLP, not entry-level data science jobs. Reinforcement learning. So this is highly specialized and rarely required for most data science roles. Hadoop and Apache Spark. While they are absolutely useful for large-scale data processing, most data scientist roles won't require this, and there are typically software engineers to help or simpler services to get the job done. Kafka. Real-time data streaming tools are more relevant for engineering-focused roles. Kubernetes. So container orchestration is essential for large-scale deployment, but most entry-level data scientist roles won't involve heavy deployment responsibilities. NoSQL databases. Databases like MongoDB, Cassandra, and DynamoDB are good to know, but less critical than mastering SQL for relational databases. Graph databases are similar. Neo4j and similar tools are great for analyzing network data, but they're not usually required in your typical data science role. Edge computing and IoT analytics can also wait. And then, controversially, I might say, the nitty-gritty on how LLMs work. I think it's great to get some experience with prompting, but you're probably not going to be asked to code a transformer from scratch in an entry-level data science generalist role. By now, you've gained foundational skills in Python, statistics, SQL, machine learning, and more, and have completed a few small follow-along projects. But here's the next challenge. Hiring managers want to see real-world experience. How are you going to get experience if no one will hire you without experience? What we're going to do here is create our own opportunities. Here's how to do it step by step. Align your projects with your career goals. At this point, you should be pretty familiar with the kinds of jobs that are out there since you've been casually applying for a few months. You're going to need to align your project plan with the expectations of the type of role you're targeting. For example, if you want to look at something in e-commerce, maybe you want to work on recommendation systems, customer segmentation, or sales forecasting. If you want to work in finance, maybe we think about fraud detection or credit risk modeling. Healthcare, maybe we do predictive analytics for patient outcomes. Or maybe we do something more general like sentiment analysis of social media, churn prediction, or A/B test analysis. You're also going to want to consider what kind of role you're aiming for in terms of analytics, generalist, or machine learning. So for analytics, we need to highlight SQL skills, dashboards, and data visualization. For machine learning, we need to focus on building and deploying predictive models end to end. And for generalist roles, we want to showcase versatility with a mix of data wrangling, analysis, and modeling. To stand out, your portfolio project should demonstrate an end-to-end data science workflow. This means showing your ability to define a problem, starting with a clear, actionable question or goal, collect and clean data. We want to source raw data through web scraping, APIs, or public data sets. This is super important. We don't want to have a project with an unrealistically clean data set. It should be something a little bit more messy and representative of the real world. From there, we're going to do some exploratory data analysis using visualizations to summarize the data and uncover patterns or outliers. After that, engineer features. After that, build and evaluate models. And then finally, communicate insights. So translate the findings into actionable recommendations using visualizations or dashboards. You might consider using Tableau, Power BI, or Streamlit to create something interactive and more fun. Optionally, you could even deploy the model if you were working on something more machine learning focused. Now that we have an idea of all the steps we're going to want to show, it's time to pick a project. Ideally, you want to pick something that's actually interesting to you. You're going to be thinking about this for a few weeks, and you're going to do a better job if it's fun and it showcases your personality. If you're not sure where to start, here are some project ideas. So you could use Twitter, Reddit, or YouTube APIs to analyze trends, sentiment, or user behavior. You could analyze public data sets like the World Bank or census data to identify trends in GDP, unemployment, or urbanization. Maybe you use some weather data to analyze patterns and build forecasting models. You could build a movie, book, or product recommendation system. Or you could do some text analysis on customer reviews, social media posts, or product feedback for sentiment or extracting insights. There's also predictive models like churn prediction, so if a customer will stop using a product or service, fraud detection, or time series analysis, like maybe building forecasting models for stock prices, sales data, or environmental variables. Once the project is complete, ensure it's presented in a professional and engaging way. It's up to you whether you'd rather have a separate professional website for your portfolio or just make your GitHub look really, really nice. Also, every time you finish a project, make sure to add it to your resume and LinkedIn. In the next section on marketing your skills, I'll go into way more detail on that. Now that you've finished your project, you've demonstrated you can actually do some stuff. It's time to use those skills to get real-world experience. My favorite hack for getting real-world experience is to offer your services to real clients for free. These projects allow you to work with actual data, address real business problems, and showcase your ability to apply data science techniques in practical scenarios. Here's how you can take initiative to gain this experience. If you're currently employed, look for ways to apply data science within your organization, even if it's outside of your official role. For example, if you work in retail, you could analyze sales trends to optimize inventory management. In a small office setting, maybe you could automate repetitive tasks or analyze performance metrics. If you're in customer service, you could explore feedback data to identify trends or improve satisfaction scores. It could be that these projects just get you the opportunity to transition to a different role, but sometimes success in these projects can lead to formal recognition in your current role. So maybe you transition into something that's a little bit closer to what you want to do. It's just important to make sure you're following all the rules about handling this data and make sure you're not doing anything you're not supposed to do. If you aren't currently employed or your current job doesn't provide opportunities for data science work, there are still tons of options. So first, start with people you already know, friends, family, acquaintances who maybe own businesses businesses or manage teams. So for instance, you might help a friend's family-owned restaurant analyze customer reviews to improve their service. Maybe you could build a pricing optimization model for someone running an e-commerce shop. Or maybe you could develop a tool to track and predict seasonal trends for a local business. If you don't know anybody, reach out directly to these local businesses and nonprofits. Small businesses and nonprofits often lack the resources for advanced analytics, but they could probably benefit from your skills. Reach out to them with a specific, actionable proposal. For instance, you might offer to create a dashboard to track donation trends for a nonprofit, analyze sales and customer data for a local store to help them optimize marketing, develop a basic predictive model for a startup to improve customer retention. Just make sure that when you're pitching, focus on the business impact of your work. Most of the people working in these organizations aren't going to understand data science or machine learning, so make sure to frame your proposal in terms of how it's going to save them time, reduce costs, or improve efficiency. Even if these projects start as unpaid, they often lead to recommendations, paid opportunities, or at the very least, excellent additions to your portfolio and resume. You can also volunteer with existing organizations. So there are platforms like DataKind and other volunteer organizations that are really excellent ways to gain real-world experience while contributing to meaningful causes. So these platforms connect data scientists with nonprofits who need expertise. Projects can really range in scope, so sometimes it's as simple as figuring out survey design to developing a computer vision model. Not only do these experiences enhance your technical skills, they also allow you to learn from more experienced data scientists and grow your network. While real-world projects with clients or businesses are ideal, don't let the lack of immediate opportunities stall your progress. If responses from potential clients are slow, keep developing portfolio projects on your own. The goal is to maintain momentum, refine your skills, and add depth to your portfolio while waiting for opportunities to come through. By now, it's around mid-August. You've learned the basics and even put it to use on some self-directed and/or real-world projects for real clients. Now it's time to focus on updating your application materials, again, to reflect your new skills and position yourself as a strong candidate in the field. First, your portfolio. I mentioned before that you can choose to have a website or just a really nicely formatted GitHub. Personally, I would just go with GitHub. Here are some really awesome examples. As you can see, these all have a clear and engaging introduction and easily direct the reader to projects. Links to these portfolios and more are in the ebook as well. If you do choose to set up a professional website, make sure it includes a brief but engaging bio, links to your GitHub and LinkedIn, clear sections highlighting your projects with descriptions of the problem, your approach and results, and your contact info. Regardless of which approach you take, each project should have its own clean, organized GitHub repo for each project that includes a README with the project overview, key tools used, and findings, well-documented code and modular scripts, instructions for reproducing the projects if applicable. One thing to highlight in your write-ups is why you made the decisions you did during the project. For example, why did you choose a specific model or pre-processing approach? This will help prepare you for interviews and show that you understood the concepts well enough to make good decisions. It's also useful to write about your project on Medium or LinkedIn to explain your process and results. You'll want to focus on storytelling, what problem you solved, why you solved it, why that matters. It's important to remember that your communication skills are also very important for data science, so creating an engaging narrative highlights an important skill for future employers. Next, we're going to make sure your LinkedIn looks good. We've already done some of this in the mid-learning check-in, but here's a checklist to make sure everything is polished and optimized. Create a clean and professional LinkedIn URL, so it should direct to your name specifically. Use a high-quality photo with a friendly and approachable expression. Present yourself as already being in the field, so say you're a data scientist or machine learning engineer. Don't say student or aspiring. Add a comprehensive list of data science and related skills. Make sure you've updated this with things you've learned since last time and keywords you've noticed in relevant job postings. List projects with concise descriptions and link to your portfolio or GitHub. In your profile summary, use keywords and action-oriented language to describe your expertise, skills, and career aspirations. Include links to your GitHub, portfolio website, and relevant articles or blog postings. Make sure to add titles and industries you want to be contacted for, like data scientist, machine learning engineer, or data analyst. If you've done unpaid or freelance work, list those projects as legitimate roles, because they are. For example, label yourself a data scientist even if it was an unpaid gig. It's also important to stay active, so share relevant projects, articles, or insights regularly to keep your profile active and kind of increase your visibility. Here are some good example LinkedIn pages. As you can see, these follow the checklist that we just talked about, with everything clean, using a lot of keywords, and really just having an overall good presentation that's easy for recruiters to find. Now we're on to your CV or resume. When updating your resume, keep it concise and tailored. Place relevant technical skills at the top, highlight your projects, especially real-world ones, with specific details about your contributions, tool use, and measurable outcomes. Just like we did on LinkedIn, if you worked on a freelance or volunteer project, just list your title as what you did. You don't need to say that it was volunteer work necessarily. Study job descriptions for roles you want, and ensure your resume includes relevant keywords and phrases. Add links to your GitHub portfolio and LinkedIn, and present unrelated experience in terms of transferable skills, so problem solving, teamwork, or leadership. In the US at least, a strong beginner data science resume should have one page only. It should have a clear summary or heading at the top that aligns with your career goals. Then, real-world projects and volunteer work, skills, tools, and technologies used in projects listed in your experience, and links to everything. Let's take a look at an example resume. Here you can see, it's just one page. Because there is a relevant certificate, the education was put at the top. Skills are also close to the top. Quick note about certificates, they aren't super valuable, but they're better than nothing, so let's keep it in there. After that, we're going over projects. And finally, professional experience, where we try as much as possible to make it relevant. Now, cover letters. Personally, I approach cover letters very differently in my career now than I did as a beginner. I think in the early days, having a well-crafted cover letter that shows enthusiasm for this particular role at this particular company, with some details explaining why, and detailing your transferable skills can be a little bit helpful at least. This cover letter is short and to the point, references something specific from their blog and ties it to the applicant's experience, and talks about the desire to transition into data science and the relevant skills. Now that we have our application materials ready and a strong portfolio, it's time to start applying in earnest. We often hear that applications are just a numbers game, and while that's true to an extent, we need to be a lot more strategic than just sending out our resume to every posting we see, and we absolutely don't want to be doing this with GenAI tools. Instead, prioritize jobs where you either have a strong chance or would really love the role. Spend time customizing your resume, or better yet, developing a network strategy, which we'll talk about next, for those roles. If you still have time after really focusing on the high probability or high payoff positions, then sure, go ahead and spam your resume a little bit. But what we want to do is avoid the cycle of mindlessly sending out applications, getting rejected, feeling like there's no point putting in the effort, so we're lazy with the next batch of applications, and so on. This is a really poor approach strategically and is bad for your mental health. Even more promising than applications is networking and putting yourself out there one-on-one. In my data science mentoring work, the people I'm seeing be successful are the ones with very little social fear, to be honest. They're super proactive about reaching out to recruiters, hiring managers, and in-person networking. I know this sounds painful. Trust me, I hate doing it too, but the fact is that this is absolutely the highest leverage tool we have in our tool belt. If you have little or no industry experience, automated resume screening systems might filter out your application. Reaching out directly to a recruiter or hiring manager can bypass this initial screen and give you a chance to sell yourself as a candidate. Recruiters receive a lot of messages, so keep yours short, respectful, and to the point. Start by briefly introducing yourself, mentioning your relevant skills, projects, or certifications, and make sure to emphasize why you're interested in the company or role specifically, rather than sending a generic message. For example, you might send something like, "Hi, recruiter name. I'm Marina, a data scientist with skills in Python, SQL, and machine learning. I recently completed a project where I built a recommendation system to improve customer engagement for an e-commerce dataset. I'm particularly interested in this company because of your focus on a specific product, value, or challenge. I'd love to connect to learn more about what you look for in data science candidates. Thank you for your time." So that's pretty general. We could do a little better even. Recruiters and hiring managers are looking for people who can solve real problems. Instead of just saying that you're interested in the role, we can even take it a step further by showing how your skills and projects could add value. First, study the company's products, recent news, and any challenges they might be facing. LinkedIn, company websites, press releases, or even industry reports can give you ideas. In your message, suggest a few ways your data science or machine learning skills could address specific needs. So if the company focuses on e-commerce, for example, mention how your experience with recommendation systems or customer segmentation projects could enhance their user experience. Even if you don't have direct industry experience, reference any relevant projects, volunteer work, or skills that demonstrate your ability to solve similar problems. For instance, mention a project where you analyzed customer data or a volunteer role where you optimized a process. Anything that shows how you'd contribute effectively. Data science and machine learning are valuable across various sectors, so finance, healthcare, retail, nonprofits, and more. Companies outside of traditional tech also need these skills, often for tasks like demand forecasting, process automation, or customer insights. Whether you're applying to job postings or reaching out to potential contacts, one super important thing is to remember that you're not going to get a job by focusing on how great the job would be for you, but how you're the best person to solve the company's problems. Make sure to clarify what differentiates you from other applicants and how these specific skills are best positioned to solve the specific problems outlined in the job description. You need to understand the role and communicate clearly how you plan to bring value to the company, not the other way around. For example, instead of saying, This role is exciting to me because I'm passionate about machine learning. Say, I see this role focuses on customer segmentation, and my recent project using clustering algorithms demonstrating how to drive actionable insights from user data ideally gives some other specific takeaway. Be consistent about reaching out to potential connections and being thorough with your applications for high potential jobs. And at one point, you'll start being called for interviews. Once you get an interview on the calendar, it's time to start preparing in earnest. The key thing that I do differently with interview prep is essentially I just over-prepare. I put in a ton of work in advance to anticipate what might be covered and dig deep into studying those topics so that it looks like I came up with clever, well-thought-out solutions on the fly. This is particularly important if you lack significant industry experience. Preparation will help you bridge that gap and present yourself as someone who's ready to learn and contribute from day one. You cannot afford to go into an interview unprepared. Interviews can vary widely depending on the company and the role, so focus on the common components. First, the recruiter screen. Be prepared to give a brief introduction, summarize your background, and explain why you're interested in the role. At this stage, it's important to make a strong case for why your skills align with the job requirements. Use keywords from the job description, reference relevant details from their blog or website, and ensure your elevator pitch is well rehearsed. Review your past projects thoroughly, understanding every detail, including the reasoning behind your decisions. This preparation ensures you're ready if the recruiter asks you to walk through a specific project. Whenever possible, tailor your examples and explanations to align with the requirements for the job. Finally, ask thoughtful questions to gain clarity about the role and understand the next steps in the interview process. This not only shows your interest, but it also helps you prepare effectively for the future stages. Coding questions. By now, you've been practicing coding for a few months, so you should be prepared. Make sure that you've practiced thinking out loud and coding at the same time. Remember, it's not just about getting the correct answer. Interviewers are evaluating how you think, approach projects, and ask clarifying questions. It's worth taking the time to practice coding interviews with another person who can provide feedback on those aspects. This is going to help you refine your communication skills and improve your ability to explain your thought process effectively. Now, behavioral questions. You can get hints about the kinds of behavioral questions you might be asked by reviewing the company's values or leadership principles. These often guide the questions interviewers ask to evaluate culture fit and alignment with their priorities. Prepare at least one example from your past experience that demonstrates how you embody each of these values. When answering, use the STAR method, so situation, task, action, result, and bonus R, reflection. You can use this to structure your responses effectively and ensure your answers are clear, concise, and highlight your impact. Focus on examples that showcase teamwork, problem solving, and adaptability while tying them back to the company's core values. Case studies test your ability to solve real-world problems using data science and machine learning. You can prepare for these by researching the business you're interviewing with, understanding their industry, and anticipating relevant problems, metrics, and data types. Dive into the company's products, services, and goals to tailor your approach and demonstrate domain-specific knowledge. One super important thing is to be ready to discuss how your work as a data scientist can impact this company's bottom line, decision-making processes, or strategic goals. This shows that you not only have technical expertise, but also understand the business implications of your work. Tailor your responses to align with the company's mission and priorities. For every interview stage, have thoughtful questions prepared. These could be about the role, the team, the company's challenges, or their expectations. Asking questions not only shows your genuine interest, but also helps you gain insights and better position yourself as the ideal candidate. The key to success in all these areas is to think in advance about the business to such an extent that you're able to essentially guess what the case studies will be, so you can narrow down the areas to study. I have a detailed video that goes over how to prepare for every phase of the interview process, from the recruiter call to behavioral questions to case studies. I would definitely recommend checking that out after this. I'll link that in the description. All of the advice in that video is the same for beginners, except that you're going to have more times when you do not have relevant experience to draw on. In those cases, don't panic. Pivot the conversation to how you would approach the problem. So, for example, while I haven't worked on a problem like this before, here's how I would break it down. This demonstrates critical thinking and a willingness to tackle new challenges, both of which are super valuable traits for any candidate. It's also okay to ask clarifying questions of the interviewer and demonstrate your curiosity and growth mindset. Interviewers don't expect you to know everything, but they do want to see how you think and approach complex problems. Remember, many companies hire entry-level candidates based on their potential rather than their current expertise. For example, in my first real data scientist interview, I couldn't complete the coding challenge. I was asked to implement regularized regression from scratch, which I straight up could not do. Instead of giving up, I explained the steps I would take, demonstrating that I understood in theory what to do, even if I couldn't execute it in the moment. After the interview, I spent the weekend coding the solution and sent it back to the interviewer asking for feedback. I can't say for sure if that's why I got the job, but I think It hopefully showed some extra dedication and willingness to put in the work. This level of effort can set you apart, especially when competing with candidates who probably already have experience. Remember, every interview you attend, even if it doesn't result in an offer, is a valuable learning experience. The more you practice, the more comfortable and confident you'll become. Breaking into data science is hard work, and it might take longer than you expect. But with determination, preparation, and a willingness to go the extra mile, it's absolutely possible. Again, I make 5 times what I did 5 years ago because I stayed focused and consistently worked to improve. Your effort will pay off too. So now, how to do well when you start your first job. Congratulations, you've landed your first data science role. Starting a new job can be intimidating, especially in a technical field like this one. I think I spent the first 6 months or so at my first job basically panicking every day that I did something wrong. But that's okay, it did get better over time. Here are some suggestions on how to do well when you do start that first job. First, understand the business context. Your first priority should be understanding the company's goals and how your work fits into the bigger picture. This means learn what metrics matter. Find out what KPIs your team and company care about and why. Understand the challenges. Read up on industry trends, internal documentation, or past projects to get a sense of the business's pain points. Talk to stakeholders. Ask them or team members what problems they're trying to solve and how your work can help. Building this understanding early on will help guide your decisions and make your contributions more impactful. Next, ask questions and seek feedback. It is okay not to know everything. No one expects you to at this point. What matters is that you're proactive about learning. Here's how to approach this. So, ask questions. Whether it's about the company's processes, tools, expectations, don't hesitate to ask for clarification. This shows initiative and just like a general desire to get things right. Get feedback often. Ask for feedback on your work from peers, mentors, or managers. The sooner you know what you're doing well and what you need to improve, the faster you're going to grow. Next, leverage your team. You are not in this alone, hopefully. Your team is your greatest resource, so don't hesitate to pair program with colleagues and learn from code reviews. So take those reviews seriously, see them as opportunities to improve your skills. If you can, find a mentor, and generally just try to build strong relationships with your colleagues. This is going to help you learn faster and also just create a more supportive environment. Next, focus on delivering value. In your first few months, aim to contribute to projects that provide visible value, even if they're small. So maybe you just automate a small repetitive task or create a simple dashboard or visualization. Maybe you optimize an existing process or improve a basic model. The key is to deliver results, even incremental ones, because this builds trust and establishes your reputation as someone who actually gets things done. Also, stay curious and keep learning. The learning doesn't stop once you're hired, or ever, truth be told. You're gonna need to continue to build your skills by exploring new tools and techniques and learning from mistakes. If something doesn't work, just treat it as a learning opportunity and keep on going. Becoming a data scientist in 2025 might feel like a monumental challenge, but with focus, persistence, and a clear roadmap, it is absolutely within your reach. Remember, this journey is a marathon, not a sprint. It's not about mastering every tool or algorithm under the sun. It's about building a strong foundation, solving real problems, and demonstrating your ability to drive business value. If you're feeling overwhelmed, don't worry, that's normal. Take it one step at a time, stick to the timeline we've laid out, and keep pushing forward. The most important thing is just stay consistent, stay curious, and keep building, whether it's your skills, your portfolio, or your network. Also, don't forget that all of the info that we covered here in this video is available for free in the ebook linked below, so make sure to check that out. If you're worried about systems to put all of this into practice, I have a video on how I study consistently with a full-time job. Learning never ends in this field, and I'd recommend checking that out next so you have the best possible chance of success in the coming year. Thanks for watching, and good luck! You've got this.